Welcome back. We are working on Cal 1 today. We are doing derivatives. So this is just math, y'all. As soon as I start talking, I start coughing. So I hope this won't stop me from finishing this video. Okay, so today we're doing the product and quotient rule. This video will just get us through product rule, and then I'll do another one in a little while on the quotient rule. So my version of the the product rule is just real simple. The first times the derivative of the second plus the second times the derivative of the first. And no other book I have found that writes it that way, but my version is equivalent to what you find in all the other versions because multiplication is commutative and addition is commutative. So I don't know why I do first times the derivative of the second plus the second times the derivative of the first, but that just always made sense to me, and that's what I do. So, and that's what my notation is indicating. Again, it is the exact same procedure that you'll find in a textbook. It's just for some reason they like to do it a little different. Final answer is still the final answer. So here we go. So we're going to do the example I have here. And so the first function is the x minus the 4, so that's your first one, and that's my second one. Okay, x plus 3 is the second one. So I'm going to write the first function is x minus 4, because this is two things multiplied together. And then I'm going to multiply that by the derivative of the second one. Well, we learned how to do the derivatives. And using just the little power rule, this is going to be a 1x to the 0 power, or just 1. We learned that, so that derivative of the second is 1. All right, plus the second function, which is the x plus 3, times the derivative of the first one. Well, the derivative of x is a 1. The derivative of 4 is 0. It's a constant. And then I've got to simplify this. Well, this is pretty easy. There we go. So x plus x is 2x, and a negative 4 plus 3 is negative 1. And so that's it. Now, if you actually multiply out, because you could actually multiply out those two binomials and get a trinomial and take the derivative of the trinomial. But the idea is that you don't have to. You're going to learn this new rule for finding the derivative of two functions multiplied together, because multiplying it out is not always the best way to do it. So polynomials, however, you can do either way. So for this next example, that's the first one, and this is my second one. Okay, and so for the derivative of the function, I'm going to do the first times the derivative of the second. So there's the first one. Now the derivative of the second one, we're going to do a little power rule, so that'll be 4x minus 3. Hit the big plus, so that's the first times the derivative of the second, plus the second one, which is 2x to the second, times the derivative of the first. So on the first, we're going to get an 8x. Remember, derivative of a constant is 0. All right, so now I do have to simplify this out. I am going to multiply and combine some like terms, but all that is just tedious. You should know how to do it, but it's tedious. I'm just going to quickly go through it. 16x to the third minus 12x to the second minus 32x plus 24. This I'm going to distribute. There we go. All right, and then I'll combine my like terms, and I get a 32x to the third and a minus 36x to the second, a plus 8x plus 24. So that's the derivative right there. And if you had multiplied out the polynomials, the binomial times the trinomial, and did the derivative, you would get that as well. So there's those two. Let's try two more. Here we go. Okay, now these are a little trickier because of the square root. And I probably only have time for one of them in this video. So I'm not going to do this one right now. I'll come back to that in a few minutes. Let's do this other one. Okay, so now this is the first. And this is my second. Okay, so the derivative is going to be the first, which is t to the 6th, times the derivative of the second. So now I'm going to put that over here to the side. That's the second function. And to do the derivative of this, I'm going to rewrite it as t to the 1/2 plus 4. That's just a rewrite. And then I'm going to use my little power rule so that the 1/2 goes out front. And then I have to subtract 1 from 1/2, so that's going to give me a negative 1/2 as my exponent. So I have 1/2 t to the negative 1/2. And then, of course, the derivative of a constant of 4 would be 0. All right, so now what is this? Well, we're going to leave it like that for now, okay? But that's the derivative of the second. All right, so we're going to do t to the 6th times the derivative of the second plus the second function. I'm going to use, again, the radical is going to be changed to the fraction times the derivative of the first. Well, the first derivative, the derivative for the first function is 6t to the 5th. Okay, I'll let that be my scratch paper. Okay, so let's look at it again. I've got the first times the derivative of the second plus the second times the derivative of the first. All right, and so that's the first function and that's the second one. Okay, now that's not so bad until now. Now it gets weird. Now simplifying this with all these fractional exponents is really going to be a pain in the butt. And so that's why I have this scratch paper over here, because I'm going to need it. All right, I'm going to need it. So first of all, I've got to multiply these two together. Okay, so that's going to be a 1/2 for sure. But then what? Well, remember when you multiply things, you get to add your exponents. It's one of our exponent rules. And so just kind of refresh your memory. If I did x to the 3rd times x to the 4th, then I would get x to the 7th. I can add my exponents. So in this problem, I got t to the 6th times t to the negative 1/2. So I got to add 6 and a negative 1/2. Okay, so if I get a common denominator, that 6 is going to become a 12 over 2. There we go. And 12 over 2 minus 1 over 2 is going to give me 11 over 2. So this is going to be a 1/2 t to the 11 halves. Now just hold on. That looks crazy, I know, but it is correct. All right. Now, the next one, we've got to distribute. So again, I'm doing 6t to the 5th times t to the 1/2. Well, it's going to be a 6. And this time I've got to add 5 plus 1/2. Well, again, this is going to, 5 is going to be 10 halves plus 1/2. So that's going to give me, 11 halves again. So when I do that multiplication, I'm going to get 6 t to the 11 over 2. Okay, and now I've got to do that multiplication, and that's going to give me 24t to the 5th. Okay, now these are like terms. Those are like terms. So when I do like terms, I have to add the coefficients. So once again, I have to add 6 plus 1/2. This would be 12 over 12 halves plus 1 half, which would be 13 halves. Okay, so this is going to be 13 halves t to the 11 halves plus 24 t to the fifth. And that is the final answer. And you're like, well, what about that radical? In calculus, we really don't care about radicals. We take those radicals and we turn those into fractions. Why would you do that? Well, look at all these cool rules we had with fractions. I mean, with exponents. And we can do them with fractions. So that's why. All right, so that's f prime of x for that one. It's just math, y'all. That was a doozy right there. Yeah, that was hard. So think through the product rule and let's get used to this radical stuff. All right? Keep trying.